Hello, welcome to this video. This is an A-level further maths video on core pure mathematics, book 1. We're going to look at chapter 1, which is on complex numbers, and section 1.1, where we're going to introduce ourselves to imaginary numbers, to complex numbers, and we're going to do some very simple arithmetic, adding and subtracting them. So let's get started. I'd like you to solve this quadratic equation, please. If you could use the quadratic formula to solve it, I'll pause, or I'll ask you to pause the video. Pause the video. Once you've got your answer, then restart. Okay, so hopefully not too difficult for further mathematicians such as yourself. What you should have done here is you should have ended up with the quadratic formula. We'd end up with x equals minus 9 plus or minus the square root of 25 all over 4. And of course you can simplify that to end up with x equals negative 1 or x equals negative 7 over 2. So hopefully you got that right, no problems with that. Now, I'd like you to try and do the same thing with this particular quadratic equation which we've put on the screen here. This one, the process breaks down. I'd like you to try it, so we'll pause the video. Let's try this and try and answer the question, what stage does the process break down when you're trying to solve this particular equation using the quadratic formula? Okay, so again, this one I think hopefully if you're familiar with that quadratic formula you shouldn't have too many problems with at least starting this question. When you try and use that quadratic formula though, you should end up with x equals 6 plus or minus the square root of negative 64 all over 10. And you might stop here because you're looking at this and thinking to yourself, well, that negative 64 under the square root might be a problem. So if we are going to make progress, we need to know about this square root of negative 64. What are we going to do with that? So that's the question then. What are we going to do with this? We'll pause the video, have a look at the question on the screen and choose one of the options. Well, of course, the answer is that the square root of negative 64 is neither 8 or negative 8. We've known for quite a while now that there is no real number, whether it be positive or negative, which you can square, which gives you a negative answer. So we're still faced with a bit of a problem here. What are we going to do about this? Well, let's see what we can do with this. Let's take our negative 64 square rooted. Now we do know some surd rules here, so what I'm going to do here is I'm going to see if we can split up that negative 64 and we'll write it as 64 times negative 1. And of course our surd rules tell us that we can split that up again and we can write that as 64 square rooted multiplied by the negative 1 square rooted. Root 64 is of course 8, so we end up here with 8 multiplied by the square root of negative 1. We still have this issue with the square root of negative 1, what does that mean? But I think one thing we can do with this is we can make things a bit neater. Let's just introduce a bit of notation for us here. Let's introduce the symbol I here, and we'll say that I is going to stand for the square root of negative 1. So whenever we see the square root of negative 1, we'll instead just write I, just to kind of make things a bit neater for us. So that means that we end up here with the square root of negative 64 is 8I. Now, of course, I is just a symbol here. It means the square root of negative 1 in our notation. We haven't really talked about what that itself might mean, but for now, we'll just kind of go with that. Let's do another one. So if we have the square root of negative 36, say, we can split that up. We can write that as 36 times negative 1 under the square root. Do the simplification using our surd rules. We end up with the square root of 36 multiplied by the square root of negative 1. Square root of 36 is of course 6, and the square root of negative 1, we're going to use this symbol I. So therefore we have square root of negative 36, we can write as 6I. Okay. Time for you to have a go at one now. So quick question on the board there. How could you write the square root of negative 25 in terms of this new symbol I? Okay, so hopefully you're getting the idea by now. You should have written that the square root of negative 25 can be written as 5i, like that. Okay, so time for a definition here. What we've been dealing with here is we've been dealing with things called imaginary numbers. The square root of a negative number, it's not a real number because it doesn't live on our number line anywhere. There's no positive number or negative number which we can square to get a negative answer. So we call these kind of numbers imaginary numbers. It's a new kind of number for us, and they can all be written in the form some multiple of I, where I stands for the square root of negative 1 here. So, with our newfound knowledge here of imaginary numbers, let's see if we can go back to that equation that we were trying to solve earlier on. If you remember, the equation was 5x squared minus 6x plus 5 equals 0. And we'd got as far as using the quadratic formula, and we'd found that x equals 6 plus or minus the square root of negative 64 all over 10. Now, of course, the square root of negative 64, we've just seen, using our new symbol I and imaginary numbers, we can write that as 8i. So the whole thing becomes 6 plus or minus 8i over 10. And a tiny little bit more simplification of that means we end up with 6 over 10, which obviously can be written as 3 over 5, plus or minus, and then 4 over 5 times this number I. So there are the solutions to our quadratic equation using this symbol I and imaginary numbers. Okay, so time for you to have a go at one yourself. Here's a question for you to do. Solve this equation. I will tell you that the roots that you get will involve these imaginary numbers. It'll involve I. So what I'd like you to do is solve this equation and give your answers in terms of I. Okay, so hopefully you've done that and got the answer. I'm just going to jump straight to the answer here. You should have ended up, after you've done all the simplifying, with your two roots of the equation as 3 plus or minus 5i. Now, you might be thinking to yourself, is there any way of simplifying this? Is there any way of combining this, this bit here with this bit here? Well, the simple answer is no, there isn't, unfortunately, because the reason why is 3 here is a real number. It lives on our number line, whereas the 5i is an imaginary number. There's no space for that on our number line, so there's no way of combining these together. Imaginary, there we go. So let's bring in some definitions here, a few more definitions here. When we have a number like, for example, 3 plus 5i, then it's got two parts to it. It's got what's known as the real part, which in this particular case is 3. So 3 is the real part of that number. And then the 5i, well, that's kind of the imaginary bit. Well, actually, we just say that 5 is the imaginary part, not 5i, but 5. There we go. And then altogether, when we have a number which has a real part and an imaginary part, then those kind of numbers, we call them complex numbers. This is what this chapter is all about. So complex numbers will often have a real part and an imaginary part. So the whole thing together is called a complex number. So let's get those definitions up on the screen here. I would suggest that you possibly pause the video here while this is on, have a read of that, and notice at the bottom where it says a new bit of symbol there, a new symbol there, representing the set of all complex numbers with that, that letter C there. So make sure you've got that before you continue. Right, so have a look at the question on the screen here. Let's make sure we've got the idea. Pause the video here and just write down the answers of these before you restart. Okay, so hopefully pretty straightforward. You should have got your real part of this question, of this number I should say, is 2. And the imaginary part, I'll just write im. So the imaginary part is, of course, 7. Notice it's not 7i, it's just 7. Right, let's see if we can do some calculations then. So in this video we're just going to stick to simple calculations like adding and subtracting these complex numbers. But let's say I had these two numbers here, 4 plus 5i, there's a complex number, and I wanted to add it to 3 minus 2i. How would I do that? Well, nothing funny going on here, exactly as you'd expect. If you're used to collecting terms together with algebra, which I'm sure you are, you'll just be able to get this one very easily. We can look at the real parts here, the 4 and the 3, those add together to make 7. The imaginary parts here, we've got 5i here plus the negative 2i, so those two imaginary numbers will combine together to make plus 3i, and there is our answer. Okay, so here's one for you to do. Pause the video, make sure you get the answer before you restart. Okay, so you should have got the answer there. That's the solution to your little subtraction that you're doing there. The real part is going to be 2, and the imaginary part there is 12, giving us a complex number of 2 plus 12i as your answer. Hopefully you got that right. Okay, let's do another very simple calculation. Make sure we can do this sort of thing here. What do you think we would do to get the answer to this one? So I'm going to take 3 multiplied by this complex number, negative 2 plus 3i. Well, again, nothing funny going on, nothing dodgy. We'll just expand brackets out in the way we've been doing for years using algebra. So the answer here is 3 times negative 2, which is negative 6, and then 3 times the 3i gives us 9i. So there is our answer for that one. Okay, so here's another quick one for you to have a go at, slightly more complicated. We've got 3 complex numbers there which are being combined together. Pause the video, work out what the answer is, and restart when you're ready. Okay, let's just jump to the answer here. You should have ended up with 0 plus 14i as your answer to that one there. Now, of course, we don't have to write the 0 in here, so we could have just written 14i and there. So our answer here happens to be a purely imaginary number, no real part, but we'll still call that a complex number. Okay, finally, let's have a look and see how our calculator might deal with complex numbers, because our calculator does have a wonderful complex number mode on it. So I'm going to show you how that works here with the emulator. I'm just going to quickly do the calculation which we've done here. So this one here will confirm that this one here, the calculator agrees with the answer here. So first thing we need to do is put it into the complex mode, and we do that by hitting menu here. And it's actually mode 2 on the calculator, gives us that one. So let's hit equals here, and then we will put in the calculation here. So 4 plus 5i, so 4 plus 5, and the I button on the calculator is this one just here. So if you're in complex number mode, hit that button which says ENG on it, and then you get the I. You can see on the display there you've got that. Let's just add that to the other number we want here, 3 minus 2i. I'll close the bracket for neatness, and then hit equals there, and you can see there 7 plus 3i is the answer that we've got. Okay, so why don't you use your calculator to have a go at this one here on the screen. Use the complex number mode on your calculator to verify the calculation which you've just done by hand on the screen there. Okay, so that's about the end of this video. To just consolidate what we've learnt in this video, you might want to go to the textbook and have a go at exercise 1A and exercise 1B in that textbook. That's the end of section 1.1. We'll be back with section 1.2 shortly.